Excellent. Thanks you guys so much. And I see that we already have a question about contact certificate hours. Yes, we do have letters of completion available. If you just need an informal letter of completion, we'll put up that contact information at the end of how you can get it. We also have the formal continuing education units as an option for you to attend this webinar. I'll mention all those details at the very end. On top of that, this webinar is being recorded tonight. So we have that happening too. As always, for people who are regulars to our webinars, welcome. For people who are new, we're so excited for you to be joining us. This is our, what is this, 4th? August, September, October. Yeah, this is our 4th webinar of the season, and it's all around designing bird study experiments. For those of you who haven't attended our webinars before, my name is Lindsay Glassner. I am the outreach coordinator here for the K-12 education group at the Cornell Lab of Ornithology. And in the chat window tonight, monitoring it, drinking a very noisy water bottle too, so sorry, is Kelly Schaefer, who is our education specialist. Julie! Oh my, okay. As Kelly's getting very excited to greet people in the chat window, I can tell. Let's get started for tonight's webinar. For those of you who are new, we are using the Zoom's webinar platform. And we do try and make our webinars interactive. So if you can, look for the chat window down at the bottom. Looks like a little quotation bubble. And it will pop up on your right-hand side. And you'll see that it says a to box. And if you can make sure that to box says to all panelists and attendees, that will allow some really great interaction between not only you, Kelly, and myself, but also the other participants. We have found that over the years we've done this webinar that you don't just want to hear from us. It's really beneficial to hear from other educators who are interested or have done similar activities, can provide recommendations. So allowing your comments in the chat window to be visible to all attendees is really beneficial. So let's test out that chat window. Where are you from and what is your role as an educator? I know several of you have already started typing that chat window, but feel free to do that again as we speak. And it's so nice to see several familiar names. Okay, we have Wisconsin, Connecticut, Nevada, Maryland, Columbus, Ohio, Michigan, Georgia, North Carolina, Oregon, Indiana. I know we have Canada too, Utah, Missouri. Wow, lots of states represented. It is so wonderful. And I'm seeing a lot of diversity of educators here. Quite a few, it's looking like informal educators, but also some classroom teachers interspersed as well as some new pre-service teachers. Welcome, pre-service teachers. We're excited you're joining us too. Excellent, excellent, great diversity. California, Wisconsin, Idaho. Excellent. Well, thank you guys so much for joining us. This webinar will finish very promptly at 7 o'clock. As hopefully many of you are aware, today is election day. So we want to make sure we still give people plenty of time to leave work, go vote if you haven't done so already. Kelly and I made sure we did that before so we don't see long lines. But we do want to make sure we get you guys out promptly. So let us progress. For those of you who have not attended our webinar before, we are the Cornell Lab of Ornithology. We are associated with Cornell University, the Ivy League Institute, Go Big Red. It's nice little Cornell alumni pride there. But the Lab of Ornithology itself is, though associated with the university, a separate entity. We are our own nonprofit membership-driven institution, and our mission is to interpret and conserve the Earth's biological diversity through research, education, and citizen science, mostly with a focus on birds, but we do have a lot of other great projects, especially around bioacoustics and multimedia. But tonight's webinar is focusing on bird studies. So that's what we're going to talk about tonight. And again, we are with the K-12 education program, and our mission is to develop innovative resources that build science skills while inspiring young people to connect to local habitats, explore biodiversity, and engage in citizen science projects. Again, my name is Lindsay Glassner. I'm the outreach coordinator here, and Kelly Schaefer will be monitoring the chat window. She's our education specialist and certified bird nerd. Feel free to throw any fun questions her way, whether it's relevant to the webinar or not. Keep her engaged and excited. With all that in mind, let's get started on tonight's webinar. We're going to hope to assess what makes an experiment. We'll do a quick little compare and contrast between an observational study versus an experiment. We're going to review some common mistakes that many kids and educators have when designing and implementing an experiment. And then we want to explore opportunities for students to share their projects through what we have as our national challenge. Now, during this webinar, we will highlight three main bird study experiments that frequently are submitted to us for our student publication magazine called BirdSleuth Investigator, which I just realized I completely forgot to put a slide in for potentially. But those three experiments around feeder color, food preference, and novelty experiments, we'll talk about those and give you time to assess the experiments, talk about how they can be best set up, and hopefully brainstorm some ideas of what you can do to inspire your kids to participate in feeder studies. Now, the main content that we're discussing here, especially when it comes to setting up a fair experiment or investigation, is structured or scaffolded through our free comprehensive curriculum called Investigating Evidence. This curriculum, as I said, is a free download on our website. Kelly will share the link in the chat window if she hasn't done so already. But what she'll do in there, what that curriculum does, I should say, is take the entire science process and lay it out with how you as educators can guide students through it. And we've also aligned that to a lot of different science standards as well. So for those of you who do have to meet for, say, the next generation science standards, that's all aligned within this curriculum. To supplement the curriculum, and especially if you really want to go in depth with student investigations and citizen science, we strongly recommend looking into one of our online educator courses called Integrating Inquiry for Educators. This is soon to be updated too, so feel free to take a look at the description of this, but you can also wait for a few months and actually participate in the newer version of it. This online course is a paid course, and it's about 20 to 25 hours of work or contact time, but you can receive continuing education units for it and so forth. So we have these two options available for you to continue onwards after this webinar through our free curriculum Investigating Evidence and through our paid online professional development course Integrating Inquiry for Educators. Now, I know I saw several people had attended last month's webinar, and there are several people who this is your first webinar with us, or maybe you didn't attend last month's. So I want to just do a quick overview. This webinar is a continuation, I would say, of last month's, which was all around developing observations and questions, providing that background or introduction to inquiry and inquiry-based activities. So if you are interested in looking at that webinar, I think it provides some really great activities of how to first engage kids in nature and develop their observational skills, which will naturally start to inspire questions and how you can foster those questions to lead to investigations. So that is an archived webinar through our YouTube channel. And again, if Kelly hasn't done that already, she's going to put that in the chat window too. So let's just do a quick overview of what was briefly discussed in that, or let's briefly discuss what was in that previous webinar, just to make sure we're all on the same page. And we decided to really come to a group definition, or what we thought inquiry or investigations were. Now, inquiry, when you type it into Google, you can get some formal definitions. For example, up here on the top right corner, an act of asking for information or an official investigation. For me, when I learned about inquiry, quote unquote, I was taught the scientific method, this very linear process on the bottom right of asking a question, doing your background research, constructing a hypothesis, testing said hypothesis, analyzing the data, and publishing your results. That very linear model that we have available. Now, that has changed a little bit. So many people, there are people now who go through the process of a feedback loop between asking, investigating, creating, discussing, and reflecting. This is very similar to, say, the engineering design process, which is also very feedback loop oriented. However, this just really isn't exactly what we here at the Cornell Lab of Ornithology think about when we think of investigations or inquiry. We really like to summarize it in 3 big points of, first, having kids ask and answer their own questions, which is addressed in the definition, so to say, of inquiry of official investigations. But we really want to make sure that that authenticity, where it is the actual questions of kids themselves that are being asked and answered, that's being addressed within the science process. The next, we want to focus on this concept that inquiry investigations, this really is PBL, or project-based learning. It's allowing kids to experience it authentically again, but through an entire project-oriented focus. And between these two, it's inherently going to meet the next generation science standards through science practices. For those who aren't familiar with them or don't have to meet them, just so you know, these science practices are listed here below. There are 8 of them, and they're focused on asking questions, developing and using models, planning and carrying out investigations, analyzing and interpreting data, using mathematics and computational thinking, constructing explanations, engaging in argument from evidence, and then communicating information, evaluating that information. So as kids go through the science process that we really like to embody here at the Cornell Lab, they inherently are meeting those practices. Now, you'll see that what we've outlined here is these questions that kids can investigate really spark from their own observations. So we have along here on the left, making observations is the foundation of the science process. And that's what we addressed in last month's webinar. From those observations, questions naturally arise. And this is the starting point, really, of where the science process can progress to. Is it a question that can simply be looking up the answer to, or is it something that needs further investigation where they can be designing their own experiment or study, analyzing and collecting data? Maybe they don't have to do their own study, but solely just look at other data and then collect results from there. But ultimately, it's not a linear process or a simple feedback loop, but it really is a complex, messy situation. It all depends on what this question is that the student is asking. And based off of that question, there are many different possibilities. So let's talk about some of those possibilities. Now, as far as the types of questions that a student can ask, many of you as educators will encounter a lot of questions that we like to call reference questions, where it's simply a, oh, what is the name of that bird? That is a question that you can easily reference or look up. Or how long can a whale hold its breath? That's a great reference question. It's going to be a little difficult to develop an experimental study, I think, on that one, or an observational study on that one. Right, Kelly?
For most people, yes.
For most people, it's going to be difficult. For students, it's going to be difficult to develop an observational study about how long a blue whale can hold its breath. So that's really a reference question there. They're going to be referencing data that they can find accessible to them to find the answer to. There are also going to be questions where they can explore or analyze data, and this may be data that they won't collect themselves, but they can still interpret and analyze that data to find an answer to. A really great example of this that we encountered in one of our students' investigations that were submitted to us was a population study of bald eagles in 3 different national parks. The student was interested in which national park could you find more bald eagles in. And so that's something where, yes, if you wanted to, you can do an observational study and travel to these 3 separate national parks, which were Yosemite, Yellowstone, and I can't remember the third one. But to do that, again, it's not as feasible for students because you have to do a lot of traveling, you have to stay there, and how do you balance such things as date and time seen? Instead, what the student did was actually look up citizen science data from one of our citizen science projects, eBird, which had a massive amount of data of bird sightings in these different national parks. And so she compared the data for each 3 parks, specifically around the bald eagle. So her question, she didn't have to conduct a full experiment or observational study. Instead, she was able to take advantage of the citizen science data made available to her to help answer her question. So that's another great example of that explore or analyze data. Now, the final 2 question categories that you may encounter with kids is questions that are more open-ended, that do require kids or allow kids to do their own study. And they can either be observational studies or experimental studies. And I want to open this up to you guys in the discussion of what is the difference between an observational study and experimental study. So in the chat window, let us know your definition of an observational study or experimental study, or what the difference is between those 2. Okay, so we're getting some feedback in from our live audience here, Kelly. Mm-hmm. So we're seeing things such as words controls, planning execution, observing what happens versus conducting experiment with variables. Recording behavior could be an observational study. Manipulating variables for experimental. Experimental could involve a hypothesis. Observational studies when you're not manipulating anything and just taking data from what is already occurring. Experimental study compares 2 situations. Observational study could involve a series of observations. Interesting, interesting, interesting. When I think of an observational study, I think of Jane Goodall watching and waiting and seeing what happens. I like that. Huh. Experimental, I feel you're comparing this to a null hypothesis or variables. Null hypothesis, great word. Okay, so Sherry, that's the most recent one who just commented, and Julie as well, and both of you are saying very similar things. So an observational study would be where you are not manipulating anything, so you're just observing. For example, what Julie's saying are how many birds in a location. Whereas an experimental study, you are manipulating. You have control over specific variables, and you're testing those variables. For example, what foods do birds prefer and what types of feeder? Exactly. So, and that's really what we're going to discuss today, are the differences between those two. And that's not just work and stuff. We're going to focus on experimental study today, but we want to identify what the difference is. So again, the observational study is where we are not manipulating anything, whereas an experimental study is we have variables or controls, as many of you have already pointed out. And these are an independent variable, a dependent variable, and constants or control. Okay. And so let's first discuss these variables and controls. And again, I just want to clarify what we'll talk about for the rest of this webinar. This webinar was talking about designing bird study experiments, and that's what we're going to focus on, are experiments, variables that can be manipulated. And so the variable that is being manipulated is this independent variable. And that's being changed by us in the person. Now, the dependent variable is what we're actually going to be measuring. And for any experiment, you want to have one independent variable, one dependent variable, and the rest ideally should stay constant. They'll be our controls. So why is it so important that we only have one independent variable, one dependent variable? Why is it important to change only the independent variable? And again, I'm going to open this up into the chat window to you guys to answer this question. Why is it important to change only the independent variable? Yeah, so we're looking at several different things. You don't want to confound your results. Ooh, a lot of responses. Like, I love how interactive we are tonight, everyone. Excellent. You, Crystal, right there, you're saying you won't have a fair experiment. Thank you for bringing up that terminology. We will talk about that in the next slide. If you have more than one variable is changed, data is skewed. It keeps things simple so we can draw conclusions based on one variable at a time. If you change more than, oh, there we go. So Becca, you won't be able to determine what variable caused the effect you're looking at. Absolutely. Brittany, exactly. You want to see that the change either has or does not have an effect on the results. Yes, so what we are looking at is by only changing one variable, we want to make sure that that one variable we're changing will either impact our results or not. Is it going to affect the dependent variable? And somebody brought up the phrasing of a fair experiment. If everything except the independent variable is held constant, we can say that the experiment is fair. That means that that is the only variable that's changing, and we are solely measuring that variable. Now, let's get into one of our first examples of a very common experiment that kids will do when studying birds. And this is, will birds prefer a specific feeder color? So for this example, it is blue, red, or yellow feeders. I imagine there's probably going to be a few people in here that have seen or have done this type of experiment before. But ultimately, let's use this as a starting example to assess our constants, independent and dependent variable. So for this question, will birds prefer a blue, red, or yellow feeder? What is our independent variable? Excellent. The color of the feeder. Our feeder color is going to be our independent variable. That is what we are changing. So what then is our dependent variable? Again, the dependent variable is going to be what we are measuring. So we're looking at the dependent variable, not a constant. I want to make sure that's clear. Okay, awesome. So many people are saying that a dependent variable needs to be the number of birds at a bird feeder. The birds visiting. We want to measure birds visiting. Excellent. Now, one thing I will say when I notice this is several people are talking about same food in each feeder. That's not going to be our dependent variable. That's actually going to be a constant. We want to make sure that, yes, our feeder designs and the food found in each feeder is going to be the same. However, what we're measuring will be bird visitation. That will ultimately tell us which feeder is going to be preferred by birds, how many birds visit the feeder or bird visitation. Now, to make this accessible for several different groups, you can either designate specific counting times and you count the number of birds that frequent each colored feeder. You can look at species and do the diversity of species have a preference of feeder. Or you can also look at this of quantity of seed eaten. One way can be, without having to watch the bird feeders at all, is put in a set amount of bird seed in each bird feeder, say 1 cup of bird seed, and then measure how much seed is eaten from each bird feeder. It can be many different ways to measure bird visitation. But just for the time being of this, we're going to list the amount of seed. That way, it's not dependent on your identification levels or constantly watching a bird feeder at a specific time of day, but you're solely measuring the amount of seed that's going to be consuming the bird feeder. This is just one way to measure it. Finally, we're going to get to our constants, and several people have listed several constants already, which includes the feeder design, locations of feeder, the kind of seed. If we're going to put out several different colors of bird feeders, you want to make sure that each bird feeder is the same type. You don't want the red feeder to be a suet, the blue to be a tube, and the yellow to be a house feeder, because then you're altering the type of feeder it is. Same thing of one feeder having black oil sunflower and another having peanuts. Or if all the bird feeders are located in different locations. So those are things to keep track of constants. Several other factors that you can consider that's often not done or considered with some studies of kids is the time of day or time data is collected. I'll give you an example. One study that we've had submitted to us before is when they have measured the color of bird feeders put out, and they'll put the red bird feeder out in the same location and same type of seed as all the other feeders, but for 1 week. Then they'll take the red feeder down and then put up the blue feeder and then measure bird visitation for the 2nd week. Then they'll take that down, and then the 3rd week, put up the yellow bird feeder. So ultimately, over 3 weeks, each bird feeder was up for 1 week, but the timing was that the weather and other outside factors could be impacting each week individually. Not all bird feeders were out at the same time, therefore they did not encounter all the same factors, such as weather. So those are also things to take into consideration. Though we can't actually control the weather, we can control if all 3 independent variables are in fact exposed to the same weather. Yeah, and that's a devil's advocate right there. I just saw the comment that the seed could be knocked down. You could have squirrels eat out of the bird feeder. Those are all different options. The other thing is, if you are taking, I'll play devil's advocate on that one, it just pops in my head. If you're going to be measuring the amount of birds visit, how do you focus on what time of day do you watch them visit? Is it just going to be in the morning, the afternoon, in which case you're going to have a little bit of bias there. It's not going to be perfect, but that's where, when you're designing an experiment, that discussion section at the bottom where you're presenting your results allows you to reflect on your experiment and think, if I was to do this again, what might I modify to consider all factors?
Right, and then as you're considering these factors, which are great ones to bring up, there can be ways to try and control for those too. So I was thinking about seed falling from the feeder versus being eaten. Depending on how you hang your feeders, it's also possible to put a tray or a platform feeder beneath it to try and catch seeds. So you might be able to think of ways that you control for the other factors, like putting your feeders on poles with baffles away from anything that squirrels can jump on. I mean, it's never going to be perfect because squirrels are tricksy creatures, but it's a really cool opportunity to provide your students with chances to innovate and discuss and really think deeply about how to control for some of these factors.
And I love that. We can also have an exciting experiment of which color feeder attracts squirrels as well. Yeah, this is the science aspect, and this is why I love the fact that the scientific method isn't one linear process as well. It's quite complex. And so we try and demonstrate that too, and make sure, as Kelly was saying, have those conversations with kids. So the color feeder preference is going to be something that many people will try and do as a starting experiment. And ultimately, what comes in some of the final results of this is having kids analyze and interpret results. Here's just a sample graph that could be coming from that experiment. Again, this is taken in the total amount of seed eaten. So the amount of seed eaten, that was chosen because that was in fact a study that was presented to us. And here is their results, where the blue feeder, based on their results, is showing slight more preference of bird visitation than the red or the yellow. But this graph brings up a really great point of talking about how to, 2 points. One, how to outline your results in a clear format, in a visual representation like a graph, but also to make sure, is the data you're actually collecting answering your question? So I want to take a little sidestep and talk about bad graphs gone wrong. Now, there are many times where we have seen reports come in from students who, bless their hearts, wanted to make the most beautiful graph possible, but clearly it was not conveying very well. And this is not a mistake that just students make, but this is the Austin Bard and the Daily Illini, where this graph is very misleading to us, where it doesn't quite give us the information that we need. Here's a really great graph that I love. What grade are you in? 26% freshman, 26% sophomore, 26% junior, and 26% senior. Not only do the sections all represent different percentages, despite the fact that each one is 26%, but the fact that this is a pie chart that adds up to more than 100%. So we want to focus on the fact that bad graphs do go wrong. How they measured innovation in this, and what the difference is between the USB plug and the iPhone, I'm not really sure at all. But rest assured, kids, that you're not the only one making a mistake. Should Scotland be independent? 52% no, 58% said yes. Again, we are 110% right that mistakes happen. in this page here, these are all come from 13 graphs that are clearly lying. It's just a wonderful BuzzFeed article that we've come across that we really do like. What should cost less, a gallon of gas or a gallon of milk? Yes or no? That's a great example right there of the data they collected is not actually answering the question. And that's something that many kids will do when they start to try and collect data. That, for example, if we were looking at our color feeder preference, red, yellow, or blue, we talk about what data can be collected. And the amount of seed was suggested. We also talked about measuring the number of birds visited or species visited. But we also could measure things such as time. Were there more birds visiting in the morning or the afternoon? And that's adding a whole nother variable, and that's not actually answering the question we want. So we need to make sure, as educators, we encourage kids to think through the process, not only of what is their independent variable, but what is that dependent variable, and is that dependent variable actually going to answer the question we are proposing? We don't want to get the kids in a situation of what should cost less, a gallon of milk or a gallon of gas, yes or no. We want to make sure that it actually says gas or milk, not just yes or no. So let's continue our conversation about good graphs. And I want to throw the question out there of what makes a good graph. Clear labels, titles, simplicity. Oh, simplicity is so overrated, Julie.
Overrated?
Or no, underrated. Underrated. English is underrated. Not too much information on thing. Again, going simplicity. Accurate data, measurable results, color coordination. Oh, it's so wonderful when we list the wrong data with the wrong color. Choosing the right graph for the type of data. That is huge, Mary. The scale, the type of graph. Again, yeah. Not three-dimensional. Why they made three-dimensional graphs possible, I don't know. But kids love it, Tyler. Readability, continuity between separate graphs. Absolutely. Ultimately, when we think of graphs and a good graph, it needs to be worth 1,000 words. The simplicity, the titles, you need to be able to look at a graph and understand what is it trying to convey. And that includes what was the question being asked and what are the conclusions. So we have 4 different types of graphs, and many of you guys probably know this already. Pie charts and bar graphs, those are going to be comparisons, and the pie chart obviously has to equal 100%. Whereas bar graph is going to be, it doesn't have to total 100%, but both of those are going to be comparing variables. A line graph is really great for showing a change over time. And then the scatter plot, which many students tend not to use, that's going to be for more open data and showing trends in those data. But choosing the right graph is incredibly important when thinking about what message you are trying to convey. So again, a pie chart showing proportions, a bar graph is going to be comparing categories, a line graph is changes over time, and a scatter plot are trends in data. Now there's going to be other types of graph, or you can certainly do other types of visualizations, but these are many of the basic ones that we address. So we've already talked about probably the most popular experiment that we have seen come through, which is feeder color type. But probably the second most popular one that we talked about is where we are comparing food preferences of birds. And this question pitched above, homemade versus store-bought suet, who will win? That's a title from one of our soon-to-be 2018 BirdSleuth Investigator published articles. And I'm going to be referencing BirdSleuth Investigator, so just so everybody's aware, that's our student publication magazine. Kelly is finishing up final details on that as we speak, given that she's our editor. But ultimately, every year, we have students submit their own investigations, nature writing, and artwork, and we publish that. We try and bring a full circle by having kids become published scientists in this magazine. So here's a very common example of a food preference study. And what these kids did was they want to compare homemade versus store-bought suet and which the birds will prefer. Based on that information or that question, what is going to be our independent variable, what is going to be our dependent variable, and what constants should they create? Excellent. So we already have some constants here. Having the sewage cage type needs to be the same. And then composition, brand, store-bought, recipe, homemade. And then I'm seeing from here that our independent variable. So what Laura's talking about, the independent variable, it's going to be the type of suet, whether that is going to be a homemade suet or store-bought suet. And in their description, what they talked about is going to be the independent variable of homemade suet is a recipe that they provide in their description. And then the store-bought, they didn't want to name any names. So they just classified it as one store-bought suet that's found in their local area in Michigan. Michigan, right? Pretty sure it's Michigan. Now, I'm seeing several people talk about dependent variables, and it could be how many birds visit, could be who eats which, or how many eat which of the suet. Heather's also talking about suet, could be the amount of suet that was eaten. Heather, that is actually what these kids chose to do. This is an elementary group. And so they, instead of identifying all the birds, they did choose to weigh and measure all the suets. And then many constants that people are talking about, the cage needs to be the same, the location needs to be the same, and whatnot. So here's the results that these kids had. And you'll see in the picture on the right, they are actually measuring the suet before and after of how much was eaten versus how much was there previously. And this data shows that they collected data every Wednesday of their measuring how much suet was there before and after. So to give you an example, actually the results of this were all the homemade suet, no matter what, was always eaten. It was always gone compared to the store-bought suet. And these were suet cages based on another picture they presented to us, which were side by side. So there's a clear preference for the homemade suet based off of this study that the kids did. Now, what I love about this is not only comparing the food preference, but the fact that these kids are developing some really valuable skills, not only designing the experiment, but getting their hands dirty and making suet from scratch, measuring and calculating the difference that they found between the suet, and then based on that difference, they then created a supportive graph as well. So this is just another, again, really simple food comparison. Other ones that we've seen are do birds prefer, say, black oil sunflower seeds compared to thistle or millet or what have you, or mixed seed and so forth. So food comparison seed is also another great study that many kids can do. Now, the final study I want to highlight, it was really difficult for me to find a name for it, but ultimately it's bird behavior with novelty items. Now, if you've ever attended any one of our workshops or presentations, there's a good chance that you've heard the story of Amy with her fake cat. And I'll summarize it really quickly, but Amy essentially noticed that whenever her neighbor's cat came by her bird feeder, all the birds disappeared. And so she decided what happens if she would put up a fake stuffed animal cat by her bird feeders, would the birds visit or not? And she found that the birds weren't visiting her bird feeders. Now, to me, that's a really interesting story in the fact that, are you actually assessing that the birds are scared of the cat, or are they scared because there's a novelty item that's near the bird feeders? And this is a new study as well that's going to be published in our 2018 BirdSleuth Investigator. And it's around, do birds prefer music? It was done by Jane, a 6th grader in Connecticut. And you'll see the objective of this study was to determine whether or not birds preferred to feed at a feeder with the music of Beethoven or a feeder with no music at all. And whether we assess the music versus non-music, for me, it's starting to make me think about the novelty aspect of the music. Do birds actually prefer music versus no music, or is it solely a novelty item? But you look at her graph here, and her independent variable would be the presence of music. Her dependent variable is, based on this graph, the total birds seen. And based off of the music, you'll see that the number of birds seen is actually 41, whereas the number with music, number of birds seen with no music, is actually 40. Now again, this is another one of those graphs where not ideal, because you'll see that the scale, it looks like there's a significant difference between music versus not music, but the scale is not starting at 0, it's starting at 39.4. So this is just another thing to talk about, though the concept is really cool. The graph itself is not actually conveying the message very clear. You would think that music would be significantly better, but in fact, it's not. So these are the novelty factors. Graph aside, the novelty factors can be really cool to have kids test. Some other examples that have been done are kids putting out pictures of cats, calm versus scary cats near water sources, and seeing if that affects the birds coming in. Another one is wanting to study bully blue jays, and so will the presence of a blue jay decoy actually alter bird presence? Now, if you wanted to study bully blue jays, I would recommend, instead of an experimental study, doing an observational study. Focusing on behavior, you want to take out that novelty item and instead just observe bird feeders, and when a blue jay arrives, see what the other bird behaviors are doing. So ultimately, those were 3 categories of experiments that are commonly done around bird study. One is testing feeder color, one is testing seed preference, and then this one is talking about novelty experiences with birds in a feeder situation, adding something new that they haven't encountered before where they would frequently visit. So based off of that, I encourage you to start thinking about what type of experiments may you do with your kids. Can you adapt any of these to be observational studies, such as the bird behavior with the blue jay? Can you modify some of these to make them even better, or maybe replicate them and compare the results in your region versus the other ones? For example, replicating the homemade suet versus store-bought suet, that's a very easy study that you can replicate and see if you've gathered similar results as them. But ultimately, what I would encourage you to do is think about how might you be able to study the behavior of birds at bird feeders. We now are launching officially, this is the first time I'm saying this, we are launching our national challenge. We did this again last year. We had some really great studies come in and new studies come in, so we want to launch it again this year. And what it is your students can submit any kind of bird study to us to be considered for the national challenge, as long as it has to do with focusing on behavior of birds at a bird feeder. To participate, you'll actually receive a $9 coupon for bird food. Those who are published finalists will receive bird identification poster, a $45 gift certificate for bird food, and then there will be one grand prize winner who will be featured in our student publication magazine, receive a $100 coupon for bird food, and a free membership to Project Feeder Watch. So ultimately, the national challenge, I'll have Kelly share that link in the chat window, right there. The question is this just for the United States? Anybody can participate in the national challenge. However, prizes, especially when it comes to the coupon is only with our sponsors who are based within the United States. So the coupon can't be used in Canada. However, you are not restricted by any means to be in the United States to submit your studies to the national challenge. You just can't win the coupon prizes. What you can do, though, is if you are in Canada, Project Feeder Watch is a program that can happen in Canada, so you can technically receive the Feeder Watch membership or poster. So what I recommend doing is I want to do a quick shout out thanks to our sponsors, 3D Pet Products, Better Bird, and Wild Delight, for they help provide fund these webinars as well as provide the coupons and sponsorship for allowing us to produce the student publication. But then going further with anything like there. So we'll take some questions now. Janet, I see you have a question. Can you talk about experiments or observational research for older students? Frankly, many older students also do these studies. One study that I have seen done by older students tends to be more towards data exploration. For example, there was a really interesting study done by, it was early high school, I want to say either 8th or 9th grade, around the temperature and ruby-throated hummingbirds. I think that was in our 2017 magazine. But they, however, it seems that they tend to do more data exploration. What are your thoughts, Kelly?
I've also seen a lot of observational studies from older kids. So recently we had one submitted, which will be coming out in the new issue, which was looking at the squirrels and chipmunks and how their presence affects birds at feeders, which is they were able to do because they had a bird blind at school, which allowed for a lot of close observation. So in a way that can be a more challenging type of study to do, these observational studies, which require a lot of more time on the ground.
Mm-hmm. And Tyler just made a good point too. For a lot of older studies, you really have them actually properly write the scientific paper and present their results. Like I said, I've seen, especially the bird food preference stuff and the novelty studies, I've seen that done with older students, and really what it is having them properly think about the writing components and how do they present the results thoroughly. Another question, you don't recognize the sponsors. Are they in Oregon? Yes. So our sponsors are actually smaller. They're all part of a larger commodity called D&D, but they're all smaller brands. So the 3D Pet Products are only found in Walmart. Better Birder is really found in mom and pop shops. And then Wild Delight tends to be found more in Agway, but they are far more smaller brands, which is why all three of them have combined their powers together to support us. Are there other questions? Did we miss any in the chat window, Kelly? I know you've been up to date with that.
We got most of the ones in the chat window.
Excellent. Oh, yes, certificates. Excellent. Thank you for reminding me, Crystal. Okay, so what is happening now? We offer two options. If you are a educator, mostly this tends to be classroom teachers who need formal continuing education units. These tend to be for recertification processes in classroom settings. We do offer continuing education units. Those are paid, and you can receive one continuing education unit depending on the route you go for. Kelly will add the link to that in the chat window. It's just a free webinars page. However, most people tend to be perfectly fine with our free option, which is just a simple letter of completion. That letter of completion will just state that you have done 1 contact hour, and that all you need to do for that is just email us, birdsleuth@cornell.edu, and what we will do is give you the quick PDF of the letter of completion with the 1 contact hour. For most people, especially environmental educators, that's all you need. So that's why that's a simple option there. Whereas the continuing education units, we actually do have to pay for those because they're from Cornell University. So again, for the free option, as most people want it, just email us, birdsleuth@cornell.edu. The email is on the webinar right now, but I also just put it in the chat window. Pause this real